My name is Stephen Brown. I love it. It's funny. They say that people who do reality TV fall in love with it. I was thinking, I'm not going to fall in love with reality TV. I don't like the stuff that much. Yeah, but then a few weeks in, I just started loving it. I really am falling in love with it.
I like the amount of hands-on experience you get from this production. It involves a lot of going out and shooting things.
Our graduate student is a nursing student, PhD student, so she only comes here once a week.
I know that's been the biggest challenge for me and Steve. Our subject that we're supposed to be following for the first couple weeks didn't respond at all, and that really put us behind.
But now, we got a subject, he's excited, we're excited, and it's becoming a lot of fun.
My name is Kelvin Kamfwa. I'm a PhD student in the Plant Breeding, Genetics and Biotechnology program. I came to Michigan State in the spring of 2011 because I thought I could make a difference if I study agriculture. I could get the skills and the knowledge that could make a difference. And that's when I started my PhD in plant breeding and genetics.
When you are trained at PhD level, you are kind of mature as a scientist. And I thought I had to come to the US because at Michigan State, this is where there is arguably one of the best bean breeding program in the entire US. And I was really excited to have gotten an offer to study at Michigan State because I think it gives me an opportunity, a very unique opportunity to acquire those unique skills.
I love the campus. MSU has a beautiful campus with a lot of, it's a huge campus, and I love the diversity that is here. There are a lot more international students, and that makes you feel at home.
I live with my family. I have my wife and 2 sons. Right now they are sleeping. I normally wake up very early in the morning and prepare myself to go for work. And right now it's about 7:20, and this is typically the time I have to go to about 3 times a week to go and make crosses in the greenhouse. We need to make crosses very early in the morning to avoid the flowers aborting. So
we'll extract DNA from the plants that we grow in the greenhouse, and then we bring that DNA to the lab, and we run markers on that DNA to identify those genotypes that are carrying the genes that we are looking for, and those genes for the desirable traits. Yeah, so that's how we work, and mainly it's the disease, it's the markers for disease resistance that we are talking about. Yeah. We need to play with the genetics here, move around the genes, shuffle them, and until you have a genotype that is desirable to the consumers. And to do that, you need to generate that crosses. That's just the way. It's just like human beings, shuffling the genes. But we need to force the beans to mate, because they are not going to do that. They are self-pollinated plants, but we need to force them to do that. Today, the experiment that I'm looking at is checking for the presence of the I gene, which is the gene that conditions resistance to one of the major diseases of beans, genes. So I'm going to run you through the different steps of how we do this experiment. So we went to the greenhouse, we got the DNA from the several plants, and now we need to screen those plants and identify those ones that are carrying the gene. So here, that's where we keep our DNA stocks, the DNA that we have. It's a -21 freezer. That's where we keep our DNA. This is where we also keep our primers and some of our reagents, that are supposed to be kept at a low temperature. So this is our PCR machine. So we have already some more reactions running here. My reaction has already run. And these are my samples, and then we need to take them and load them in the electrophoresis gel. So this is the electrophoresis gel. That's where the DNA is going to be moving. So there has to be voltage that will be applied on both ends, and then the DNA is going to be like dragged through that, and it will be separated according to the amplicon size, so the sizes of these fragments of the genome that we have amplified, and that way then we'll be able to distinguish which of those materials are carrying the I gene or the gene of interest that we are looking for, and the ones that are not carrying. Okay, so once we have loaded the gel, hook it up to electricity, and then you can run it at the voltage that you need. And then we take it to the documentation room. So you need to come and load it. You open that, and then we get this gel and put it there, load it nicely there. So this is the UV system. And then we come to the computer, and then you get your gel, and then you are going to have a picture which is like this. And then we need to take it to the lab for us to go and interpret the results that we are getting here. So when we take this to the lab, we are going to be looking at which of those DNA samples or we had loaded are actually carrying that gene, and we'll be able to tell that based on the results that we have here. The genotypes or the varieties that are having that gene, then we can advance them, select them, and advance them to the subsequent generations. So this is really a cool thing. It helps us to speed up our breeding process. Yeah. But the key thing we are doing here is to introgress resistance into susceptible materials, and that way once we introgress resistance, then the productivity of dry beans can be improved. That's what we have just been doing there. So you need to generate a cross, where you move pollen from this resistant line and you pollinate the variety that is susceptible. And yeah, that's the job of a plant breeder, is to initiate that cross. Yeah.